Hello, this is Mrs. DB, and we are going to continue our lesson on 1.7 transformations in the coordinate plane, starting with the check it out for example 3 here. So in this example, we are supposed to find the coordinates of this rectangle after a translation. And they give us the rule for the translation, x minus 2, so that means that every point is going to move to the left 2, and it's going to go up 4. So you find the coordinates by taking each of the coordinates they already had. So let's see. J right now is 1, 1. That's the point. K is 3, 1. L is 3, negative 4. And M is 1, negative 4. So what we're going to do is for each one of them, we're going to follow that rule. We're going to subtract 2 from the x coordinate, and we're going to add 4 to the y coordinate. So J prime will be 1 minus 2 is negative 1, and 1 plus 4 is 5. Those are the coordinates of J prime. K prime will do the same thing. We'll always subtract 2 from the x coordinate, and we'll add 4 to the y coordinate. So for K prime, we'd have 3 minus 2 is 1. 1 plus 4 is 5. And L prime, we're going to do the same thing. We're going to subtract 2 from the x coordinate. We're going to add 4 for the y coordinate. So 3 minus 2 is 1. Negative 4 plus 4 is 0. Did I do that right? Yep. And then the last one is M prime. We are going to subtract 2 from the x coordinate and add 4 to the y coordinate. So 1 minus 2 is negative 1. Negative 4 plus 4 is 0. Now you have to draw it. You can either draw it using these points that you just wrote. J prime would be at negative 1, 5. Or you can say, well, I know that I need to go to the left 2, 1, 2, and up 1, 2, 3, 4. Yep, I end up at the same point. So you have two options there. For K, K prime is at 1, 5. So that's going to be right here. Oh, I should also label these. So this was J prime. This is K prime. And then M prime, I'm going to look over here. The coordinates is negative 1, 0, negative 1, 0. So here's M prime. And then L prime was at 1, 0 right here. It's okay if these figures overlap. Sometimes they will. And then you connect them with a straight edge. Straight line segments. And the red rectangle is a translation, left 2 and up 4. This is just checking your work. They got the same thing that I did. Okay, one more example to do is just an application. This is part of a tile floor. You may see these in older bathrooms. Write a rule for the translation of hexagon 1 down here to hexagon 2 up here. How did they translate it? Let's see if we can figure it out. We're going to start by writing just a generic coordinate x, y, and then we write the arrow notation, and then we have to figure out how did x change, how did y change. So let's pick one point. They've got a point here for us. This is the corner point, or the far right point of hexagon 1, and this is the far right point of hexagon 2. Let's figure out how did this point go from here all the way over to here. So we start by going to the left, right? We can see we went to the left. We went left 1, 2, 3. So I have to subtract 3 from the x coordinate. Now I went up 1 and a little bit more. See, I didn't go up 2, I went up 1.5. So plus, I guess I'll put a decimal, 1.5. That should be our rule to move from one hexagon to the other. Move to the left 3 and up 1.5. They did a little more work. I just basically figured out how did one point move to the other point. They actually figured out the coordinates and then changed the coordinates. Figured out how the coordinates changed. Here's another example. How would I take square 1 and translate it to get to square 3? Well, let's do it the easier way, don't you think? So I'm going to start with my x, y, arrow notation, and then x. You might not be able to find an arrow on your keyboard, so you could go x, y, and then use the greater than symbol. will work just as well. So how did I change x? Here's I want to go from 1 to 3. So I'm going to start from here and I'm going to move over 1 unit. It's hard to see the coordinates on here. 1, 2, 3, 4. Yeah, 4. So I went to the left 4. So that's a -4. And then I moved down, of course. I went down from here to 1. I think this is 1, 2, 3, 4. I went down 4 too, I believe. It's a little hard to see those with the shapes on top of it. It's a little hard to read the coordinates. So they're going to go through their longer method, but they ended up with the same answer. Left 4, down 4. That's another way you could write this, is left 4, down 4. Okay, thank you very much. That ends our lesson for today.